Hello again to Jomat Simplified. Today we want to look at this very nice kind of a trigonometric indicial equation. Okay, so the question is written on the board and it says that given that 3 to the power of sec squared x plus 3 to the power of tan squared x is equal to 12. Okay, so basically we want to obtain what value or values of x satisfies this equation, and we are also told that x varies is greater than 0 but less than 360 degrees. Let us look at how to solve. Okay, so solution. We recall this trig identity that says that sine squared x plus cos squared x is always equal to 1. Okay, so if that is true, which we know that it is, I can divide through by cos squared x. So if I divide through by cos squared x, and dividing through by cos squared x, I can see this is now sine squared x over cos squared x. That gives me tan squared x. Okay, plus 1 equals to sec squared x. Okay, so 1 over cos squared x is sec squared x. So it means that wherever I have sec squared x in my trigonometric indicial equation, I can just replace by saying tan squared x plus 1. Okay, so I've been able to show that sec squared x equals to tan squared x plus 1. So replacing sec squared x by tan squared x plus 1, this equation becomes 3 to the power of tan squared x plus 1 plus 3 to the power of tan squared x equals to 12. Okay, so we know from the laws of indices that whenever we have the power adding, it can be rewritten as a multiple. Okay, so we can rewrite this as 3 raised to the power tan squared x times 3 raised to the power 1 plus 3 to the power of tan squared x equals to 12. Okay, so I can rewrite this as 3 to the power of 3 to the power of tan squared x plus 3 to the power of tan squared x equals to 12. Okay, so at this point I see that 3 to the power of tan squared x is common. So I can factorize 3 to the power of tan squared x, okay, and I'll be left with 3 plus 1, and that is equal to 12. So 3 to the power of tan squared x times 4 equals to 12. Divided through by 4, I can also see that 3 to the power of tan squared x equals to 3. Okay, now of course the exponent at the right hand side is 1. Okay, so I can say 3 raised to the power 1. Now, since we can see that the base is the same, so we can imply that equality holds for the exponent. So this implication is that tan squared x is equal to 1. Now, we have that tan squared x is equal to 1. Now, I can take the square root of both sides. So this becomes tan squared x raised to the power of 1 over 2 equals to the square root of 1. This can take care of this. We have tan x equals to, of course, the square root of 1 is 1. So I can just say it's equal to plus or minus 1. So it means that tan x is 1 or tan x is minus 1. Okay, of course we know that the only value of x that makes tan x equal to 1 is 45 degrees. Okay, so x is 45 degrees or x is just negative 45 degrees. Okay, so this gives us our value of x on the first quadrant. Okay, so what we will need to do is to look for these corresponding values of x on the second, on the third, and on the fourth quadrant, because we see that it is both x being 45 and minus 45 degrees. So when it is positive and when it is negative, satisfies that equation. Okay, so on the second quadrant, the corresponding value is just given as 180 minus 45, which is 135 degrees. Okay, on the third quadrant, the corresponding value is just given as 180 plus 45, and that is 225 degrees. Corresponding value of x on the fourth quadrant is given as 360 minus 45 now, yes, and that is now 315 degrees. Okay, so all of the solutions that satisfy that equation is given as x equals to the first one 45 degrees, the second one 135 degrees, the third one 225 degrees, and finally 315 degrees. Okay, so that gives me the solutions for x satisfying this inequality. So thank you very much, and I'll meet you on the next one.